Hey guys, hope you're all doing well. I know everyone's stuck at home and sometimes that can be a little stressful. So I thought I'd help by putting together some videos. I also know you guys got a hell of a lot of reading in here, and I wanted to make sure that the reading wasn't what stopped people. So I'm going to read bits of this to you guys. I'm also going to stop and explain it just the way I would if you guys were in a class. This is as best I can do for now. I promise I'm going to work on a few things, including, I suspect, my lighting, but we're going to see if we can get through this together. So binary numbers. So computer class without computers is hilarious, right? I will also tell you this video thing only does in 5-minute increments. So we're going to cut this off every once in a while. So binary. So it can be really helpful to think about binary. Computers actually count in binary, zeros and ones. And in fact, everything in a computer, if you go down far enough, is really just zeros and ones, little switches of on off. In fact, the earliest computers really were just switches, little on or off switches, and each different state meant something. Today, thankfully, we can use computer at digital zeros and ones instead of actual switches. These are much faster. So today you're going to start with that set of cards, and there should be at least one page in there where you have the set of cards where you can actually cut them up. And I wanted to give you guys that option in case that was helpful for you to look at these. But really all this is a bunch of cards that are base 2. Why base 2? Binary, ones and zeros. So we always start counting at zeros. It's one of those things. Yep. It's one of the pages towards the end of the binary. There's a series of those cards, and they're blank on the back. That way you can and actually try this activity as if you could count them. So one thing. So what do we notice about the dots on the card? Well, probably that every card has twice as many dots as the one immediately on its right. So as I draw out, I'm only going to draw 3 of these cards because that's what's going to fit in my little whiteboard today. Still working on some of this stuff. So 3 cards. Now, for every card that's face up, I have to count the numbers, and for every card that's face down, I don't count the numbers. And what I need to do is figure out for any number I want to make, how many cards up have to face up to get to that number. So there should be only really one way of doing it, ideally. So let's say I wanted to start with the number 8. Now let's start with, I gotta do something I can do, right? Let's start with the number 6. Turn this one upside down. Now I'm seeing 6 numbers. So everywhere a card is face up, we count it as a 1, and any card that's face down, we count it as 0. So 1, 1, 0 is how you write 6 in binary. Now these cards will actually help you until you write all the way up to 31. So if you use these cards, you're halfway there, and in fact, you can do all your binary work for this with just these cards. So let's say I drew something like this. You guys have to wait for me to draw now. Okay. Maybe you can read these, maybe you can't this time. So as I count these, 1, 2, 3, 4, 5, 6, 7, 8, 9 dots are showing. 1, 0, 0. So this is just a different way of thinking about it. And we can say then that 1009, 1001 is the same as 9 in binary. We're translating between binary, base 2, and our regular number system, which is base 10, not surprisingly, as we have 10 fingers. So we do everything in base 10. So the next page in your packet gives you an opportunity to sort of practice counting with these. So this is where I suggested you actually have some of those cards. See if you can figure out how to get to 3, 12, and 19. Can you get there in multiple ways or just one? By the way, you can also learn to count on your fingers this way. For example, 0, 1, 3. Oops, 3. There we go. 3, 4. No using this outside of class. 5, 7, 8. So in the same way, when you get all the way to 999, you're going to flip up to the next number and it'll be a 1. Here we just flip every time we get to 1. That's part of how